Niacin has long been understood, and at times dismissed, as a classical cholesterol-lowering agent, primarily used to adjust HDL, LDL, and triglyceride levels in patients with dyslipidemia. Yet this narrow pharmacological framing fails to capture the deeper biological influence niacin exerts within cells. The findings of this recent study radically expand niacin's profile, reframing it not just as a lipid-modifying drug, but as a cellular detoxifier, one that restores homeostasis in lysosomes and mitochondria, two of the most critical organelles involved in cellular health, stress resilience, and chronic disease progression. At the center of this reframing is niacin's impact on lysosomal cholesterol trafficking. Atherosclerotic lesions are not simply the result of elevated plasma lipids. They arise from immune cell dysfunction, particularly within macrophages that accumulate oxidized LDL and become lipid-laden foam cells. The key pathological trigger here is not cholesterol per se, but its improper handling at the intracellular level, specifically the accumulation of unesterified cholesterol in lysosomes. This toxic buildup destabilizes the lysosomal membrane, triggers inflammation through inflammasome activation, and leads to apoptosis and necrotic core formation within plaques. Niacin directly interrupts this pathological loop. It upregulates CD38, which drives the production of NADP, a potent second messenger that releases calcium from lysosomes through TRPML1 channels. This calcium signal activates liver X receptor alpha, LXRA, which in turn boosts the expression of NPC1, ABCA1, and ABCG1, transporters that enable cholesterol to exit the lysosome, reach the cell membrane, and be exported. In doing so, niacin relieves the lysosome of its toxic cholesterol burden, preserving its structural integrity and functional role in autophagy and cellular waste processing. This mechanism is profoundly detoxifying. By clearing excess cholesterol from a compartment where it triggers inflammatory and apoptotic cascades, niacin restores a foundational level of cellular equilibrium. And this action doesn't stop at the lysosome. Lysosomal calcium release and NAD dynamics, both influenced by niacin, have downstream effects on mitochondria, the cell's energy engines. Through NAD, sensitive enzymes such as sirtuins, and by modulating interorganelle calcium transfer, niacin helps maintain mitochondrial membrane potential, supports ADP production, and reduces oxidative stress. The result is enhanced mitochondrial resilience in the face of metabolic or inflammatory insults, another form of cellular detoxification, this time at the level of energy metabolism. What's striking about this reframing is that it elevates niacin from a molecule that adjusts numbers on a lipid panel to one that engages the fundamental architecture of intracellular health. Its benefits emerge not from lowering LDL cholesterol in circulation, but from rebalancing how cholesterol is managed inside the cells that make up diseased tissue. This intracellular activity, clearing toxic lipid buildup, suppressing inflammatory cytokine release, and protecting against apoptosis, has implications not only for atherosclerosis, but also for other diseases marked by organellar stress, such as neurodegeneration, lysosomal storage disorders, metabolic syndrome, and age-related decline. Furthermore, niacin accomplishes this without introducing foreign gene products or requiring synthetic pathway activators. It leverages existing cellular machinery, CD38, NAP, LXRA, connecting nutrient signaling with detoxification and repair pathways in a biologically coherent way. This makes it a powerful therapeutic candidate not because of its simplicity, but because of its ability to engage deeply conserved cellular mechanisms that govern lipid balance, inflammation, and survival. In conclusion, this study invites a fundamental rethinking of niacin's place in medicine. It is not merely a tool to adjust cholesterol levels, it is a modulator of organelle function, a facilitator of cellular cleanup, and a guardian of immune cell vitality in diseased tissues. By restoring lysosomal and mitochondrial homeostasis, niacin offers a form of metabolic detoxification that could reshape how we approach chronic inflammatory diseases. Its therapeutic scope, once considered narrow, is now far broader and more biologically integrated than previously imagined.